Looks like we can start now. Um, Hello, everyone who came here. It's nice to see all of you. It's hard, but it's nice. My name is Nikita Martov. I work in Evolution Gaming, to be more precise, in the video department. And today I will tell you about what do we do in Evolution Gaming and how do we analyze our video streams so they are so they look perfect and very fancy. Okay, how many of you knows how does Evolution product looks like? Yep. No, not much. Okay, so long story short, we have live studios where dealer deals real paper cards. It's a very significant part, and we film it with a camera and stream into your browser. And in browser, you have buttons to take decisions, to make decisions. And the dealer sees what you have decided and gives you one more card or doesn't give you any card. And our key thing that we try to achieve to keep this image in high quality. Today I'm going to speak about that. The story started kind of more than a year ago when the Christmas Eve was coming, and the creators came into studio of our new game Dreamcatcher and put there the snowman on the right side and the Christmas tree on the left. Christmas tree was more or less fine, but the snowman unfortunately started to deflate. It deflated and it kind of felt like that, and it was standing there for 2 days, as we found. And we thought, come on, it's not affordable for us to have such picture there. And it was the first step. Another one, check this one image. It looks like it's not so early in the morning. Dealer is about to deal the cards for you, but something is terribly wrong there. And if you pay attention, then the table is shifted to the left side. It's not in the center. The lights on the background are kind of weird state. And when we put overlay on top of the image that you get from the stream, from the camera, then overlay is hanging in the air. It's not the thing that we want to get. Other issues that we have found were the lighting of the table, where when you have lights on the top and the bulbs, light bulbs, they just degrade with the time and their light is not so bright anymore. And of course, more decorations on the bottom right side when Christmas Eve again was coming, and they put this white boa and the usernames became not readable at all. So these things are looking complicated, and you cannot test them with your regular unit tests, and you cannot test them with the kind of just plain comparison, pixel by pixel. Overall, all setup in our studios is pretty complicated. You can see that we have a lot of camera. For example, this particular table have 10, but we have tables that are having even more cameras there. So it's not a surprise that someday someone will bump into this camera and it will be off. So far, we were having a few QA guys that were sitting at their PCs and watching all those streams. But if you know that that Evolution Gaming is a big company, you can imagine that we have 500 tables or even more. And it's hard job to do, to sit and check all the tables all the day long. Of course, we have devices as well to check how looks the game user interface and the stream by itself on all kind of devices. And the last one point, the Trouble Buster, that's the name of the system today I will talk about. The plan of today's talk. We will see which test do we perform. I will tell how do we perform tests and some problems that we have faced during implementing those tests. As I have said, we have a lot of tables, we have even more cameras, we have a lot of people working on the floors. They sometimes run because they have missed their shift or things like that happens. And we don't have only one studio, but it's spread all over the world. We have in Malta and Georgia studios as well. So it's not only Riga problem. Yeah, and it's all the stuff is operating 24/7. Just to make clear how structure of the tests works, I will start from the user interface to make clear that we have a table, and for each table we run different tests. In this case, we have five tests for the blackjack table, And pay attention to the orange one, the histogram, and we have orange exclamation mark. That means that something there is wrong. Later we will get back to that test exactly. Of course, for each table you can see the history of performance tests, you can see the Jira details, Jira tickets that are assigned, and some more useful stuff, but it's fancy justing. Let's start with the exposure test. It's the first test that was implemented, and it works until today. It works the same as it was made, but it does not work so well as we would like to. The main reason for this test is aim is to check how bright the cards are. For example, on the left side, you can see that all cards are grayed out. They look like untidy. That's only because there is not enough light. And 84 digits numbers mean that it's 84% bright. When 100, it's completely white, and 0 is completely black. On the right-hand side, we have a much better example where the cards meets our kind of coloring standards. Unfortunately, measuring different cards is not the whole problem. In the same card, if it's put in different table positions, it may have a different kind of brightness because the lights may be uneven there. For that, we have took the OpenCV library that performs kind of mathematical operations with the images. And if you see on the background, there on the top left part, the coins just put on the white sheet of paper. And by doing some erosion and calculation stuff, we can get and count amount of coins on the bottom right side. So we have made similar pipeline for our cards. Let's get to it. On the top, we have a bunch of frames that we are about to process, and we just grab one frame and do following things with that. I will not read, just trust me, it's complicated stuff. Yes, so we delete the table, we leave only white parts of the cards, and in the result, we get the kind of mask where white pixel stands for every white pixel on the card. And then we are able to get only those white card pixels, get average of them, and then calculate the average value. For previous example, it's in the middle, this one, it's 91% of the whiteness. So in the same way we do for all groups of cards, and for one screen, for one frame, we get those values. After that, we just check if the values are within our kind of thresholds, and if it's fine, then it's fine. If it's not fine, then it's not fine. It's simply as that. And on the right side, you can see the history of this table, and you can see that the light, it just does not disappear in one moment, and as time goes forward, the light kind of degrades partially there. Yeah. And for this one particular case, we have analyzed approximately 1,000 frames to get only one kind of solution decision. Is it fine or is it not? Another kind of test that we perform is LED test. We named it in this way only because of we try to find LEDs on the table. Why is it significant? Why do we do like that? Because sometimes camera, as I have said previously, camera is off. And if we film, for example, 10 degrees higher than we expect, then UI, user interface that we put on top of the table does not match the table at all. And with the arrows are shown the LEDs. Here they are in the case when the UI matches perfectly. And this is the case when camera is off, and accordingly to that, UI is off as well. We try to avoid that things. And how to detect that case? It's simply as that. We just find the LEDs on the screen and validate if the LEDs positions are right. So simply as that. Okay, just one step back. Who knows what the machine learning is about? How many of you are confident with that? How many of you have tried the machine learning to do by themselves? Okay, it's a kind of 10 people here. Who knows what is this about? But for the rest part, I will say shortly, machine learning tries to learn from the data that you have given to them to the algorithm and try to make prediction for the values that it never have seen before. A good example and classical example for that is predict house price from the house kind of surface area. And the red dots are historical data that you have collected from the previous experience. And the green line is kind of low that you have found for this for this problem. And when you have new house that you want to evaluate, you just find the price that stands over here. That's it. That's the short story about that. Yeah, the machine learning, it's kind of complicated task, and it's a buzzword in the last days. And if usually say like that, if the machine learning is written in the PowerPoint, then it's AI. But if it's in Python, then it's really true machine learning. Today we're talking about AI. Sorry, guys. First approach, getting back to the LEDs, first approach how we tried to find the LEDs was the Har Cascade. Har Cascade, it's I took the Har Cascade realization from the OpenCV library, and to do that we just threw in some bunch of positive and negative samples with the LEDs. You can see them on the bottom, and the algorithm tried to find pattern that matches the right side, this one, I mean, this part of LED samples, and would not match the left part. Later on, algorithm just goes through all the images and tries to find points where its pattern matched the best. Okay, now you know about machine learning, at least first step, and you can update your CV. So the Har Cascade, when we when we fed the screenshot of the table into our system, we got the outputs like that. You can see the green and yellow squares there. The green squares are for kind of correct LED detections, and yellow one for incorrect. If you look deeper, then you will see that those are the nails of the dealers, and unfortunately Har Cascade doesn't care if it's nail or LED, it just finds it similar. Yeah, this solution worked almost for a year. It was more or less okay, but then I have found the one Kaggle competition that was organized by Airbus company, and they asked developers to develop algorithm to find and count the ships in the open sea. You can see on the left side one image of that. So, and the original image is this one, and after processing, you were expected to give out this one image. So in the yellow color, the ship was colored, and in the violet, the no ship area. And I thought, we have the similar case, because area of the ship in the sea is so small, the same as we do. The LED has a very, very low amount of pixels if we count against the full image size. And we tried this approach. So we took the image, we divided the image to blocks 64 times 64 pixels. We put it into our machine learning model, and we got out the mask for that. After that, we have compiled all the responses of the neural network, all the blocks, output blocks, and we got this image in the end. Okay, the next step, logical, would be to find the centers of these LEDs, but it didn't work very well because the output was a little bit noisy, and we had problems here and there. Oh, and this slide was about how the machine learning, when it's just started the learning process, we can see that some of the samples are being detected okay, and the rest are not being processed so well. But when more epochs went by, the machine learning this neural network started to perform better, and we were able to get this noisy output in the end, unfortunately. And then we thought, hey, if the neural network is able to give us such kind of output, why we cannot ask to give the precise coordinates for each LED there? And we tried this approach. We took a little bit different neural network architecture. It's named VGG19, and the output was changed by 4 kind of neurons on the output, but it gave as output 4 float numbers. When the x and y were x and y coordinates of the LED on this block, and z the presence of the LED probability that there is a LED within this block. And on the top you can see the examples that neural network predicted to us. So this solution worked the best. And to train that, we needed to label the dataset. Dataset was labeled manually with the GIMP editor, and it looked like that. So we take the image, we add another layer, we color in the white color everywhere where the LED is, and then save it. As a result, we got 120 images for that. Images were separated into groups for training and validation, and also augmentation was applied there. Augmentation is one very, very cool thing to do with the images when you process images, because neural networks usually require much more samples that you can label by yourself manually. And by doing some simple transformation, you can increase your data set. If you will see here that we have one and the same image all over this 8 kind of times, but it's a little bit transformed. It was flipped from right to left, the colors were changed a bit, and I don't know, the blur was added, for example, here on the bottom. But from the labeling perspective, it's one and the same image. Yep. And then we started the training process. Those days I was young and green, and I was using the Jupyter notebooks to train that. And yeah, it looked like that. You just start it and it goes, improving the metrics that you expect to get out. In the end, we got kind of good precision that we were expected to get. And precision was approximately 3 pixels from the origin point. That means if you have labeled that position of the LED is somewhere here, and the neural networks predicted here, you just calculate the distance between 2 points and you get, in average, 3 pixels. And for this third coordinate that I have been talking about, the Z coordinate, we had accuracy approximately 98%. That was enough as well. The training happened on the Amazon EC2 machine, and I took the cheapest one, and it was enough. Because I was able to leave this training for a night, and in the morning, after 8 hours, we got this model. But actually, it could be stopped even faster somewhere here after 2 or 4 hours, but it was night, and I was not able to stop at night. Yep. So if you think, okay, 8 hours times 90 cents, it's only $7.20. It's cheap enough, but it's not so good as it looks like, because it was not the very first experiment. It was not even the second experiment. It took more than 3 or 4 weeks to get such results in the first time for me. So yeah, get ready for that. And how the algorithm looks in the end, we just grab one block of the image, we put it in the model and ask, hey, where the LED is, and is it there or not? And we get the precision 3 pixels, as I have said before, and the 2% of accuracy, 2% of error for LEDs or no LEDs. And if the correct LED position was more than 14 pixels away from the target position, then we counted this test is failing. Okay, the next one test is the histogram tests. Maybe some photographers here know what a histogram is about. Yeah, I have seen one hand, it's awesome. But histogram, it's about when you count the pixels, and if you just go through all the pixels on the image, and if you've met the dark pixel, the black, then you count +1, you make this left bar a little bit higher, and if you find gray pixel like this, you add bar over here, and if it's white, then on the right side it's kind of obvious. And by analyzing histograms, you can say if your image kind of okay or not okay. We use particular this one test to detect the dusty prompter or dusty lenses, as you like to name them. So when you have a camera that films the tables, after some time dust just sits on the glass, and the colors became not so bright and shiny. And in this case, you can see that the deepest dark part have moved to kind of value of 30. So that means that you will never ever get black. You will get kind of dark gray. And in reality, it looks like that. So on the right side, there is dusty part. You can see the dealer's vest is kind of dark gray. And on the left side, that after we have kind of fixed this issue to clean the prompter and the LEDs, oh, not the LEDs, but lenses, we got much better and cooler image there. Yeah. One more test that we perform, it's a change detection test. You have studio and there are a lot of things in the studio happening, and all the time something appears, something disappears, something moves back and there, and we would like to know about all of those things. Yeah, and I will need some assistance from you, kind of participants here. Can you find me the 3 differences between those 3 images? One more thing. I have Evolution Gaming head scuffs for here, for the neck, and I will share them for the best questions or for best assistance for me. Yep, go on. Yeah, it's kind of changed. The guy changed it again to girl, but this changes happens all the time, and we are not expecting to detect those. It would be a kind of misdetection. Maybe flowers. Yes, flowers on the back. It was a Saint Valentine Day coming, and the decorators put the flowers on the back. Yeah. Heart on the table and the voucher, yes, on the left side. That's right. All the 3 parts. And if we would compare those like that, we would get same output like this. Okay, more complicated example one. Have ideas? Paper. And the second one? What's on the right side? Here, yes? Yeah, there was a curtain that was covering the studio next by, that was located right behind this table, and someone just touched that curtain, and if their game would be happening, then you would be safe. Then you would be able to see the dealer that deals cards there. Yes, and we have detected those as well. That's how it works. And on the left side, you can see here a little bit curtains were changed, but it's kind of unsolved problem yet, and it's pain because if you even detect that curtain was changed, you are not able to put it back in the same condition as it was before. Yeah, unfortunately. And to do this thing well, we just get averaged screenshots. We take 7 hours of the images and average them, and then compare almost directly. And this art, kind of state-of-art image, is about when your body is somewhere here, but mind wanders around, and you're kind of just dealing cards, not thinking about what you're doing. Yeah, and just list of issues that we have spotted to show that algorithm works. Yeah, that LED drivers went off on the left side. Here for this game we have bubble panels on the back. There is a water tube with the water, and bubbles just come up. And one day we saw that there is no water. Not enough water. We thought it's a leakage. We ran it into studio and asked the technical guys, come on, you have all electronics under the floor. It will be a disaster. And they said, no, it's not a big deal. It's not a problem because water just evaporates from that. And we said, oh, okay. Flowers just get moved by some reason from sometimes it's not a problem, but sometimes if this flower would be covering some I don't know, wires or other technical details that were not seen before, it might be an issue. Yep, you like you would be able to say that one of the girls doesn't have heart, but in reality the just uniform changed, and the white chest looks more different from the red kind of this dress. That's why we have detection there. The lights went off, and these situations, they occur almost every day, and no one notices them because no one goes and checks, okay, if the lights are on, check. If there is no flower, check. no one does that. And when we get such alerts, it's very handy and we can fix them rapidly. The pillars of the building we thought moved on the left side, but in reality it was just the decoration, don't worry. LEDs burns out, and there are LED strips, and one or few LEDs goes off. The same as previously, LEDs on the right side. Yeah, and this one case is, I don't know, it was my one of the most funny one. We found an issue on the right side, but unfortunately this table was not located in Riga, and we called the guy who works in there in Malta, and we asked, hey, Johnny, can you help us? We have an issue there. And he said, one moment, I will go and check this. And he went there, and we were not getting some news from him for some time. And then he came back and said, it's just a handle from the stool. And we said, okay, at least dealers will have comfort there. Yeah, and as the same as all previous algorithms, this one have problems. For example, as I have said, the curtains, the cleaner ladies that move all the pillows around every day, and false alarms. Yes, as you have said, that dealers changed from the girl to a boy. Sometimes, rarely, but it fires alarm as well. Yeah, we're about to end, and this is the last test that I will tell you about. This the close wearing out. As you can see, the table is covered with this. It's a blue color. You cannot see it here, but you will see it later. With the blue colored cloth. And here, next to the scanner, there is a white dot. It's a hole in this cloth. And we, as operators of the perfect and owners of the perfect image, we try to get rid of those. And what do? I will tell now. So after dealer plays some amount of cards, dealer has to change the shoe. And when dealer puts a new shoe on next to the scanner, he rubs or she rubs the cloth, and it makes holes, unfortunately. Yeah, here you can see magnified examples. On the left side, you can see the bad example with this one, white dot, and here it's perfect after the cloth was changed. Yeah, and this is animation, how cloth appears. If you just pick all images where shoe is not in place, you can make animation like that, how hole grows by itself. How we solved this issue? We took, again, neural networks because they performed well with the LEDs. We labeled the data set, and we got thing like that. So we divided the problem into steps. First step, find the images that have no shoe on that, so we would be able to see full region of interest. And when we have a kind of clean and ready to analyze for analysis images, we just predict the values. Yeah, and after making prediction for a kind of 5 images, we can get average value and say if the table is right or it's not. The labeling part and design of labeling approach is the most complicated that I have met so far. And we were not able to collect the data from the first time correctly. And it's always kind of problem and experiments. But in the end, we ended like that. So we have 5 folders, and the assessor guys were just sorting the images to those folders. So first one was when everything is fine, second scratched, third and fourth are critical, and the fifth was not measurable because something covers the region of interest. And after that, we just took 2 groups. The first one for the shoe detection, so we combined those 4 and try to predict when image is one of those on one or one of this. And I'm talking about this step. And for the second step, we just took groups separately. So in this way, we were able to get accuracy approximately 97% for shoe-no-shoe detection, and mean average error about 0.4 for the kind of score of the wearing out. Yeah, and the one problem that machine learning have so far is that you have assessed some, you got some data, you got some model, you trained it, you got even the accuracy for this model, and you know that the model performs well. But when you deploy the model into live, you might get problems because live data may be different from the data that you have collected for training, and you will never know what accuracy does it have there before if you will not kind of relabel it there. And the problem we have met on the live when the production, as I told before. So we have never ever seen, and we have never trained the model to detect the white shoe. All the shoes were transparent, and there we met white. That's why our accuracy dropped. Of course, it was not 0.6, it was a kind of 0.8 or 80% of accuracy, but still you got the problem. And after that, we have added just the buttons in the report, so the QA guys who are checking the report, they are able to relabel images. And after that, we got this value, exactly 0.6. So the perfect pipeline might look like this on the right side. When you train, you detect, you verify, you relabel, and then you go again from the beginning, almost from the beginning. And in our case, we just we merged the data version 1 and the production data and got better model than it was here. Yeah, and for next kind of step, we would do the same again. One more thing, just a fancy thing that I would suggest you to monitor your monitoring if you will build one, because by looking on those charts that I like very much, you are able to find some defects, bugs, and stuff. And in this way, after the root of the problem was here. Our system did not perform well, but when you check this on your local machine, everything works fine, and even exposure test that takes almost 20 minutes to complete on the local machine was running fast and smooth. But when you deploy it, works slower. So it's the next test for next step for improvement. Yeah, I would like to thank you for attention, and I would like to kind of advertise one society. It's Open Data Science Group. They are open-minded kind of guys. They do this. They have Slack channel that you can join, and yeah, and ask your machine learning and data science related questions there. But one thing that you have to go here and press this join Slack button. You will have to fill the form, and then you will get access there inside. But it's very great place to ask your questions. And I hope one day we will be able to detect all kinds of troubles in our studios, and I'm ready for your questions if we have time. Yep, looks like we could do that. Any questions? Yep. Grab the microphone.
Hello.
Hello.
On one slide with pillows, smooth. Yeah.
No, this one. Yes.
Yeah. Table actually moved. How did you? Why it's not?
Table got moved. Yes.
Yeah.
Okay, it was not detected because we kind of tried to skip all the super small movements, and we make blur to this average screenshot with the size of the kernel of the 7 pixels. So all the movements that are less than 7 pixels are just skipped. Why do we need that? Because images that we are processing are coming after encoding. And if you know for example, JPEG artifacts, that they might add some noise. And if you will not denoise, and by blurring in our case, you will get alert for all the image. But it should not hurt like that.